In 1955, Neil Armstrong became a research pilot at NASA's Flight Research Center in Edwards, California. Here, he flew almost all of the Century series of jet fighters, the F-100, the F-101, the F-102, the F-104, and the F-105. He also piloted the F-5D, the KC-135, the B-47, and his first flight was in the P-51. During this time, he served as a launch pilot on the extensively modified B-29 that was used to air launch the X-1E. He also flew the X-5, the first aircraft capable of sweeping its wings in flight, a technique in use on the F-14 and B-1 today. While at the Flight Research Center, Neil made several flights in the X-1B, a rocket-powered airplane that eventually reached speeds of up to 1,600 miles per hour. And in 1958, he was named as one of the original 7 pilots for the X-15 program, which was later acclaimed as the most successful rocket-powered research aircraft. Specializing in stability and control, Neil worked closely with engineers in developing an adaptive flight control system that would eventually allow the X-15 to fly near orbital altitudes. He piloted the first 4 flights on this system in the number 3 X-15 and later received the AIAA's prestigious Octave Chanute Award for this effort. Although originally developed in the 1950s to increase man's knowledge of hypersonic aeronautics, manned spaceflight was the immediate beneficiary of the X-15 research program. The program dramatically demonstrated the capability of the human pilot for employing a fantastic variety of acquired skills, sensing, judging, and coping with the unexpected. The X-15 was air-launched from as far as 300 miles from its destination. The rocket engine would only burn for 90 seconds until its fuel was exhausted, and the aircraft would continue to climb ballistically to altitudes in excess of 300,000 feet and speeds of over 6 times the speed of sound. Yet, barring any unforeseen mechanical problems, the pilots were almost always able to maneuver their hypersonic glider to a landing within 1,000 feet of their intended mark. In the early 1960s, Neil became involved with the development and testing of a new concept that was being considered for use as a possible method of recovering both manned and unmanned spacecraft. Although the concept showed promise, subsequent testing revealed operational problems that made the paraglider more suitable to hang gliders than spacecraft recovery. It was during this same time that Neil, flying a prototype jet fighter, developed a technique for the abort rescue of a new manned spacecraft under consideration. It was called the X-20 Dinosaur, and it was built for the U.S. Air Force. It would have been launched into space using a Titan III booster. Once in space, the X-20 would orbit the Earth using a principle called dynamic soaring. Once the speed decreased, the spacecraft would re-enter the Earth's atmosphere and land like a simple glider. In all, Neil logged 2,600 flight hours in over 900 flights at Edwards, and all before becoming the most famous astronaut of all time.
This was one of the most exciting places in the world at that time. The flight test world was filled with excitement. Dozens and dozens of new concepts and configurations in test, something new to talk about every day. And I believe that whenever I have the privilege of visiting here again and years ahead and ask someone, what's new? There'll always be something.